You see this question, first of all, don't be afraid of this question by seeing this much big diagram. Okay, it's just a simple concept. This question is given in GATE 2014, the subject digital. 5 JK flip-flops are cascaded to form the circuit as shown in the figure. Clock pulses at a frequency of 1 MHz. This is the clock pulse applied at 1 MHz and the frequency in kilohertz of the waveform at Q3. So at this point, you should get what is the frequency. Okay, before going to this solving of a problem, you should know the concept. For a JK flip-flop where J and K are connected to 1, okay, and the frequency of the waveform will be half of the input clock. Okay, the frequency of the waveform Q0 frequency will be half of the clock frequency by 2. This is similar to T flip-flop also. For a T flip-flop, it is also equal to half of the clock frequency if T is at 1. So these all are JK flip-flops, 5 JK flip-flops where J and K are connected to 1. You can see in each and every flip-flop. This is flip-flop number 1, 2, 3, 4 and 5. So here frequency at Q0 equal to half of the input frequency applied. Input frequency is 1 MHz. 1 MHz divided by 2, that equal to 0.5 MHz. So that is frequency of Q0, and this Q0 is giving to the flip-flop number 2. Now frequency at Q1 is equal to 0.5 divided by 2, 0.25 MHz. Now frequency at Q2, where is Q2 here? Frequency at Q2 is half of this, 0.25 by 2, that equal to 0.125 MHz. So the frequency at Q3, which is the required thing which we need to find it out. So frequency of waveform at Q3 is half of this, that equal to 0.125 by 2, 0.0625 MHz. If you need to write in kilohertz, that is 62.5 kilohertz. This is the required one. How we have find it out is, for a JK flip-flop, if J and K are at 1, the frequency is half of the clock frequency applied. This is called divide by 2 counter. Divide by 2 counter. If any model of this given, you have to divide just by 2. Okay. So likewise for a Q0, the clock frequency applied is 1 MHz, divided by 2 is 0.5. So at here 0.5 MHz will be there. Okay, at here 0.25 MHz will be there. At here 0.25 MHz will be there. At here 0.125 MHz will be there. At here 0.0625, that is 62.5 kilohertz. If they were asked at Q4, you can simply divide by 2. Q4 equal to 62.5 divided by 2, that is equal to 31.25 kilohertz. Here it is equal to 31.25 kilohertz. Okay, in this way we can solve this kind of questions.